Now, Unit 2 marks question. First thing, 2 marks from the table. Okay, which one? Difference between half wave rectifier, full wave rectifier. Two circuits are there: center tap, bridge, center tap, transformer, and bridge rectifier. Okay, from this, they can ask any parameter. Okay, as a 2 marks question. Okay, now we will see the differences. Half wave rectifier, center tap, transformer. Okay, here parameter. I will give some space. Here it is parameter. Half wave rectifier, center tap transformer, full wave rectifier, bridge rectifier, full wave rectifier. Now, first we need to know this center tap. Center tap transfer. Now, the first point parameter is EDC. EDC is equal to this DC voltage. First, before that, how many diodes we can use? Okay, number of diodes. Number of diodes. Number of diodes. Number of diodes. Half wave rectifier 1, center tap 2, bridge wave rectifier 4. Okay, next one is DC. DC voltage. DC voltage for half wave rectifier is Vm by pi. Vm by pi. This is 2 times 2 Vm by pi. Here also 2 Vm by pi. The next one is VRMS. VRMS. This is Vm by 2. This is Vm by root 2. This is also Vm by. Next one is okay, same IDC, IRMS. IDC is Im by pi. Here 2 Im by pi. Here it is 2 Im by pi. The IRMS is Im by 2. Im by root 2. Here also Im by root. Next efficiency is parameter. Half wave rectifier, center tap, full wave rectifier, bridge. Okay. Now parameter is efficiency. Efficiency is 40.8% efficiency. This is 81.2. This is also 81. Now ripple factor. 1.21, 482, 0.48. Up to now, center tap transfer bridgeway all are same. 81.2%, where 81.2%. All are same. Which one will change? Peak inverse voltage will change. Peak inverse voltage is this is Vm. For center tap transformer, 2 Vm. For bridgeway rectifier, Vm. Bridgeway rectifier. Okay, these all are the differences. They can ask, okay, what is the efficiency, what is the ripple factor, peak inverse voltage. Okay, these all they can ask. Okay, how many number of diodes in half wave rectifier, full wave center tap transformer, full wave bridge rectifier. Okay, these all they can ask from the table. Next, here, define, okay, define efficiency. Next question, there is a chance of ask question is define efficiency of rectifier. Efficiency of rectifier. Define efficiency of rectifier. Answer is, we know that okay, efficiency you can write as a PC by PAC into 100. Is a percentage. 100 in the sense percentage. But it is a ratio of DC output power by AC input power. It is called efficiency. Okay. So, next question is define ripple factor. Ripple factor. Define ripple factor. Okay. This is the answer is measure of purity of the DC output of a rectifier. Means how much purity will be there. Okay, DC output. How much purity will be there? That we can call it as a ripple factor. Ripple factor definition. They will ask for half wave rectifier it is 1.21. For center tap for both center tap and bridge we have 0.4. Okay, here also efficiency for half wave rectifier is 41.2%. For full wave rectifier both the circuits 80.6%. 40.81. Okay. Next one is peak inverse voltage. Define peak inverse voltage. Peak inverse voltage. Peak inverse voltage. Definition is a maximum voltage. Is maximum voltage. It is a maximum voltage across the diode when it is not conducting. It is not conducting, or when it is not in reverse bias. When it is not conducting. Okay, the maximum voltage, peak inverse voltage, the maximum voltage across the diode when it is not conducting. That is called as peak inverse voltage. These definitions they can ask. And next, Next one is define rectify. Define rectify. Define rectify. Okay, then answer is define rectify. It converts AC to pulsating DC, pulsating DC. Or another words, converts okay bidirectional signal to bidirectional signal to unidirectional signal. Unidirectional signal. Bidirectional signal to unidirectional signal. Define rectify. Next one is define clipper. Define clipper. Okay, clipper is a circuit. Okay, before going clipper, types of filters. What is for this? Purpose of filter. Next question is purpose or use of filter. Use of filter in rectifier. What is the answer? Filter can remove ripples in the ripples are unwanted signal. Okay, ripples in the output of rectifier. Output of rectifier. Remove ripples in the output of the rectifier. This is the purpose of filter. Next, types of filters. Types of filters. First type is okay C filter. Second one is L filter. Third one is LC filter. Fourth one is CLC filter. There are four types: C filter, L filter, LC filter, CLC filter. Now, define clipper. Define clipper. Okay, clipper circuit. Clipper circuit. Clip the portion of input signal. Clip the portion of input signal. Now, types of clipper. Next question, types of clip. Okay, there are different types. First type is positive clipper, negative clipper, positive biased clipper, negative biased clipper, etc. Next one, define clamper or application of clipper. Application of clipper. Application of clipper. Okay. The answer first point is it is used to separate the signal. Separate the synchronized signal, synchronizing signals. Okay, next, limit the voltage is used to limit the voltage. Use it to limit the voltage. Okay, to remove noise spikes in the signal. To remove spike, noise spikes the noise spikes in the signal. This is application of clipper. Next, define clamper. Define clamper. Define clamper. Define clamper. Clamper is a circuit to fix positive, to fix peak, peak voltage of a signal to a certain value by shifting its DC level. By shifting its DC level. DC level. To fix the peak voltage of a signal to a certain value by shifting its DC level, called as clamper. Next one is this is about 2 marks question. Now 10-mark question. See here they can ask 10-mark question. They can ask, okay, explain operation of the carries. I will write for half wave rectifier. For half wave rectifier, they might ask operation. Okay, EDC, IDC. Okay, efficiency, and ripple factor. They can ask anything. Operation, okay, VDC, IDC, efficiency, ripple factor. Okay, we know that the circuit diagram everyone know. For half wave rectifier, here we have step down transformer. Okay, here it is V0. Here it is the signal we can apply. This is 220 volts signal. Here it is 12 volt signal. This is a circuit diagram. Plus minus. This is RL. Diode D. This is anode terminal, cathode terminal. Then we can write for a positive half cycle. Okay, diode VA is greater than VK. Then forward bias. Replace with short circuit. Then V naught is equal to VI. VI. Okay, for positive half cycle. Positive half cycle. Okay, this is the way we can do the calculations. Okay, sorry, operation. For negative half cycle, VA is less than VK. Then diode is in reverse bias, open circuit. Then V naught is equal to 0 volts. Then we can draw the circuit diagram is like this. This is a signal omega t Vi V naught of omega t will get. For positive half cycle, we'll get the signal. For negative half cycle, it's 0 volt. This is half a rectifier. For this, we will find out EDC, IDC, VRMS, IRMS. You can refer that my notes. Okay, you will get these are. And efficiency is equal to find out efficiency, VDC by, sorry, EDC by PAC. That is equal to VDC into IDC by VRMS into IRMS. Okay, for this we'll get 40.2%. And ripple factor is equal to square root of P square RMS by P square DC minus 1. In this one, you can substitute these all. So these values we can obtain. Okay, VDC, how we can obtain? 1 by T integration of 0 to T Vm sin omega T. Okay, V square RMS, that is equal to square root of 1 by T 0 to T Vm sin square omega T d omega T. Okay, like this we can find out VDC and VRMS. Please, okay, you can verify my notes. And next one, second type, same, center tap transformer, full way rectifier. For this one also they can ask operation, EDC, IDC, VRMS, IRMS, okay, efficiency and ripple factor. These all we need to find. Same like that, bridgeway rectifier also. Okay, bridgeway. But the circuit diagram of center tap transformer, bridgeway rectifier is, here we can use step down transformer only. Okay, but it is divided into center. Here one diode, here one more diode. These two diodes short each other. Here one resistor, RL plus minus. The same circuit also can draw. Same circuit, center tap transformer, diode D1. Both are in same direction now. Okay, then there get RL. This is plus minus V1. Both are same circuit diagram. Center tap transformer. Now for positive half cycle, D1, D2. D1 will be on, D2 will be off. For our negative half cycle, D2 is on, D1 is off. Okay, you see that on my notes. Okay, next one, bridgeway rectifier. For bridgeway rectifier, center tap transformer, sorry, step down transformer, and we can note down the bridge here. See, this diode which direction? Same here also, same direction. Here this diode is in which direction? Here also same direction. Okay, in between these two, RL will be there. This is bridge way rectifier. This is bridge way rectifier. Okay, you can see the same thing. Okay, now filters. See, filters to avoid ripples in the output the rectifier. Okay, output of the rectifier called filters. The filters, I will explain the circuits. There are four types of filters we are having. The filters circuit, and I will explain direct answers how to write. First one is, see, in the filters there are four types. I already said capacitive filter, inductor filter, next one is LC filter, CLC filter, right? Now first, before going to know about the types, capacitor you have to place parallel to the resistor, parallel. Okay, parallel to the load. Inductor you have to place series to load, Then first capacitor filter circuit diagram. Capacitor means we can use only capacitor. Okay, if you take half wave rectifier, any circuit, okay, capacitive filter with full wave rectifier, which one? Center tap, anything, center tap transformer. See, now center tap transformer, full wave rectifier is connected to ground. Here one diode, here another diode. This one is connected here. We have RL, right? This RL, I'm going to write here RL. This is a load, right? Okay, now capacitive filter means capacitor has to connect parallel to the RL. Capacitive filter, okay, to the RL. This is capacitive filter. This is capacitive filter. Okay, you can write anything. The capacitive filter is a circuit diagram. Then full wave rectifier you will get. See, a capacitor allows AC, blocks DC. Therefore, the waveform of the output, okay, full wave rectifier we are having. Full wave rectifier output is this one. See, we already know that DC portion is how much will be we are having. VDC portion is we are having 2 Vm by pi means 60. Okay, 60% something. Okay, VDC is equal to 2 Vm by pi. Okay, you will get 60% of the DC we are having. Therefore, the DC level has to maintain the capacitor. Then we will get the output is. Okay. See, this is up to DC level. Then it will go to the peak. Then up to DC level, because this is a DC level. Up to DC level, up to the DC level. up to the DC level. Okay. And here, main thing, ripple factor formula you need to find out. For ripple factor, we will get the value is 1 divided by 1 divided by 4 root 3 F into R L into C. Okay, this is a ripple factor formula for capacitive filter. Capacitive filter. Next, inductor filter. Inductor filter. See, just now I said this is center tap transformer. This is center tap transformer. Okay, in this, okay, inductor filter means inductor need to place. Okay, inductor need to place series with RL. Okay, here it is RL. RL. Then I need to place inductor. What we can call it, inductor. Okay, for this inductor filter, we'll get the ripple factories. Ripple factories RL by 3 root 2 omega into L. 3 root 2 omega L in 3 root 2 omega into L. Okay, next LC filter. Next LC filter. I'm explaining circuits directly. LC filter. See here, LC filter is a first L will be there, later C will be there. See, that's why inductor should be, sorry, I drawn here wrongly. Inductor in the sense, sorry, here RL, inductor in the sense, I have to draw like, sorry. That. So LC filter. LC filter in the sense, LC filter in the sense, first L, inductor is series with RL and capacitor. Then CLC filter in the sense, CLC. C means first one capacitor and one inductor and one capacitor. CLC. Okay, these all are the circuit diagrams of capacitive filter. Okay, capacitive filter, inductor filter, LC filter, CLC filter, and clipper. First, for circuits are divided in two types: positive clipper. Okay, that one, the basic positive clipper, series clipper, shunt. Series clipper, shunt. This one series clipper, we have positive, but here also positive. Now, first series clipper we will see. What is the series? See, we apply series clipper. Now the diode is connected series to the resistance. That's why it is called series clipper. And we have across R, can take. See, this is very simple. Okay, very simple analysis. If they ask, explain series clipper, explain series clipper. They ask, okay, can write. Okay, for one thing I do analysis for positive half cycle. So what's going to be happen? This is anode terminal. This is cathode. Okay, VA is greater than VA. Then diode is in forward bias. You can replace with short circuit. Then short circuit resistor R. Then plus then V naught is equal to get VI. For negative half cycle. Okay, so let's say negative half cycle. Then what's going to be happen? A is less than, then diode is in reverse bias, then open circuit. For positive half cycle. This is negative half cycle. Negative half cycle, K is negative, Ek is connected to ground, right? Then there is no current flow, V naught is equal to 0. Now if you see circuit diagram, see here, this is a full cycle, Vi of t. Then we got for positive half cycle, for positive half cycle, for negative half cycle, so positive half cycle, we got positive and negative half cycle. This looks like rectifier or not? Yes, it is rectifier. This is series clipper, and here which portion is clipped here? Here which portion is clipped here? Negative portion is clipped. Negative portion. So this is called as Q. Okay, same like that. Okay, we'll get positive flipper. Positive flip. Positive flip. Sorry. One series positive. One more thing. The transfer characteristics we need to draw. Transfer characteristics. Transfer characteristics we need to draw. Transfer characteristics is thing that E naught is at y-axis, I is at x-axis. V naught versus V. See, V naught is positive in the sense. Okay, we will get. See, if VA is positive, we'll apply V naught also positive. We'll get then we'll get linear. And if you apply VA negative, V naught is 0, right? V naught is, this is the transfer characteristics. Okay, next one. Series positive, series positive, then we'll get diode is in this direction. Here it is RL, can apply the signal. This is this and this. Now this is anode terminal. Now this is cathode. Now if you apply positive voltage, positive half cycle, cathode is positive, anode is connected to ground. Then here VA is less than V. VA is less than VK. Then diode is in reverse bias. Okay, then open circuit. So understand? See here, positive half cycle cathode. Diode is in reverse now. Diode is in which direction? Reverse direction. Cathode is positive, anode is connected to, okay, 0 volts. This is 0 volts. Here it is something like a 5 volts. VA is higher. Open circuit. Then V naught is equal to 0 volts. Now for negative half cycle, this is minus 5 volts, this is 0 volts. Then VA is greater than VK. Diode is in forward bias, short circuit. So then V naught is equal to, then I can get the circuit diagram is, so for positive half cycle 0, negative half cycle will get like this. Okay, this is VA of T, not of. Now transfer characteristics. Now tell me, this is VI, x axis VI, y axis V naught, y axis V. Now VI positive, positive side will get, VI is positive, positive half cycle, VI is positive, will get 0 output, then negative. Okay, this is about negative. This is about positive side is positive, stable, will get shunt. Here, diode, this, diode and this. So you see the operation. This is anode. That is for positive half cycle, okay, forward bias. Then short circuit. Then V naught. The short circuit, the total current flow in this direction. Then 0. For negative half cycle, the current parallel. Output and the diode is parallel. Here is diode and out That's why it's important to see how how to tell you and sample with fixed capacity. Yes, sample in case of this sample, like offer diode and sample the diode is